There are moments in the history of space science when the universe seems to deliberately resist our expectations, when every carefully built model, every simulated orbit, every projected light curve suddenly collapses like a sand sculpture under an unexpected tide. Today is one of those moments a day when the predictions that felt so solid yesterday now appear almost naive. For weeks, astronomers have been bracing themselves for unusual behavior from 3I Atlas, our third officially confirmed interstellar visitor. But no one, not even the most conservative analysts, expected a deviation of this magnitude. The new trajectory update confirmed by independent pipelines. Multi-agency orbital solvers and deep space relays arrived in a burst of contradictory clarity less than an hour ago. The data was crisp, the numbers unambiguous, and the movement unmistakable. ATLAS has shifted direction again. Not violently, not chaotically, but with a smooth precision that refuses to fit any known natural mechanism. In angular terms, the shift looks tiny, a fraction of a degree, but when applied across the scale of interplanetary geometry, it translates into tens of thousands of kilometers of displacement, and this displacement is widening with every passing hour. This is the fourth such incident since late September, the second in just 3 days. And each one pushes the object further outside the corridor of standard cometary behavior. Today's shift appears temporally aligned with the remnants of a coronal mass ejection still rippling through the heliosphere. But the behavior itself contradicts what solar particle pressure should have produced. There is no asymmetric brightening, no sudden bloom of dust, no fan-shaped plume. No spike in rotational instability. The coma remains unusually smooth and featureless, as though the object is wrapped in a veil of uniform material that refuses to break apart under solar influence. Its bizarre sunward antitela formation that theoretically should not persist under these conditions continues to stretch forward, like a gravitational paradox that defies textbook modeling. Right now, the object is sinking into its minimum solar elongation, nearly swallowed by sunlight. Earth-based telescopes are effectively blind, leaving only a handful of spacecraft and off-axis orbiters capable of tracking it. The timing could not be worse. A government freeze has temporarily halted several public-facing data feeds, creating the most poorly timed information blackout in years. Yet Mars, almost ironically, has become our best observation platform. Multiple rovers and orbiters have been capturing frames of the object as it crosses its closest approach to the red planet. Yesterday's sequence from the Martian surface contained something that sent a tremor through every astrophysics lab reviewing the footage. A razor-sharp, linear streak. Bright and fast, slicing across the sky in several consecutive frames. It was not a cosmic ray hit. The direction did not match star trails. The exposure smear aligned precisely with ATLAS's predicted velocity vector. No satellite around Mars occupies that position. No known spacecraft could produce a signature so clean across consecutive frames. The simplest explanation, however unsettling, remains that the streak was Atlas itself, moving at nearly 70 kilometers per second, using its apparent magnitude and the geometry of the streak. Researchers estimate the nucleus could be at least 5 kilometers wide, potentially larger. That size places it among the biggest interstellar bodies ever directly imaged inside a planetary system. And yet, it moves with a kind of quiet defiance, altering its course without shedding observable mass. Models attempting to replicate the motion require either an impossibly deep, hidden jet that inexplicably emits thrust without releasing visible material, or an entirely new category of thermal structural reaction within the nucleus. Something that does not resemble any conventional volatile sublimation. Even more puzzling is the timeline. After the September CME, the coma should have expanded dramatically as solar radiation tore through its outer layers. Instead, the coma remained compact, the antitail maintained its eerie symmetry, and the whole object stayed aligned with the ecliptic plane far more closely than any interstellar object should. Now the deviation timeline reads like a sequential list of contradictions. the first anomaly after the CME, the subtle drift on September 27th, a larger correction on October 2nd, and now a new measurable shift, today's one, pushing it further outside predicted bounds. When the expected map of its orbit is overlaid with the actual path, the result looks like two different objects traveling through two incompatible realities. ESA's Mars Express and the Trace Gas Orbiter are, at this moment, attempting multi-band captures. If successful, they may produce the sharpest imagery ever recorded of an interstellar nucleus. But tracking a shifting target at relativistic speeds from another planet requires real-time corrections that even modern software struggles to compensate for. Later this month, as ATLA slingshots toward perihelion, its speed will peak near 68 kilometers per second. Under normal circumstances, the nucleus would erupt in activity. But Atlas has rejected every conventional rule so far. JUICE is scheduled to observe it from a unique vantage point, but the Sun itself will disrupt its communications path for weeks, possibly delaying the data until 2026. China's Tianwen-1, the UAE's Hope Orbiter, and several other missions remain potential contributors if they choose to participate. If data from all three agencies were combined, humanity would possess an unprecedented multi-spectrum portrait of an interstellar visitor. Infrared thermal signatures, ultraviolet scatter profiles, dust density gradients, spectroscopic fingerprints, plasma interactions, and nucleus morphology. With these, scientists could finally determine whether Atlas is a comet, a hardened interstellar shard, a chemically exotic fragment, or something we have no classification for. But until those datasets arrive, humanity is forced to navigate uncertainty. And so we reach this strange moment, a moment when predictions dissolve faster than explanations can form. When every new update reshapes the narrative we thought we understood, each deviation compounds the next. Each shift widens the gap between expectation and reality. And the strangest part is not the motion itself, it is the silence surrounding that motion. A body this large accelerating through space should show signs of stress: jets, fractures, plume asymmetry, rotational wobble, thermal spikes. But Atlas shows none. Its brightness curve remains steady, neither flaring nor collapsing. Its coma remains smooth, neither fragmenting nor blooming. Its tail structures, especially the baffling sunward anti-tail, behave as though bound by a hidden symmetry. When compared to Oumuamua's non-gravitational acceleration in 2017, the differences are stark. Oumuamua's motion was stable, even as its behavior puzzled researchers. Atlas instead seems to be adjusting its path repeatedly, almost as if reacting to environmental changes one piece at a time. Not intelligently, not deliberately, but dynamically through mechanisms that have yet to be measured or theorized. Some researchers quietly speculate about exotic materials shaped by conditions we have never seen, perhaps forged in radiation environments far harsher than our Sun's. Others consider deep crystalline carbon structures that respond to heat in slow waves rather than sudden eruptions. Another minority suspects layer geology inside the object shells of different compositions reacting to solar input at different thresholds, producing micro-adjustments in trajectory too subtle to illuminate the coma. These ideas do not imply anything artificial. They imply something profoundly unfamiliar. And unfamiliarity is the heart of scientific discovery. As Earth remains blinded by the Sun's glare, Mars becomes our unwilling ally. Every rover frame, every orbital pass, every grainy streak against the Martian sky is now a lifeline of information. But the window is narrowing. In a matter of days, Atlas will reach superior conjunction. And then briefly the world will see nothing. No telescope on Earth, no automated survey, no optical array will be able to track its position. When it emerges again, its trajectory may be transformed. The coma may have expanded dramatically, not at all. The nucleus may appear fractured or perfectly intact. The antitail may vanish or lengthen. Every possibility carries a different scientific significance. For decades, astronomers have dreamed of observing an interstellar body through perihelion. Now that the opportunity has arrived, the timing coincides with the most disruptive data blackout in years. When the object reemerges, our understanding may either sharpen or unravel further. This is the uncomfortable truth. We are watching an object that refuses to act like anything we have cataloged. It is not an ordinary comet. It is not an inert shard. It is not a passive wanderer simply obeying the gravitational curve carved for it by the sun. Instead, it behaves like a system reactive, responsive, evolving guided by internal processes we have not yet mapped. Whether those processes are chemical, thermal, structural, or something entirely unknown remains a question suspended in the void. As the hours pass, the trajectory continues to update in near real time. Each new solution diverges slightly from the last, like ripples radiating outward from an invisible disturbance. The scientists watching from mission control rooms around the world do not speak of extraterrestrial engineering. They speak of exotic chemistry, of hyperstable refractories, of deep cryogenic fractures that propagate silently, of mineral phases that contract instead of expand under heat, of ultra-low volatility crusts forged in interstellar cold. These are natural explanations, but they are unfamiliar. And unfamiliar is enough to challenge the boundaries of our models. The coming weeks will determine everything. Atlas is approaching perihelion, the point of maximum speed and maximum stress. If it holds together, the nucleus may reveal structures no other mission has glimpsed. If it fractures, the debris trail will provide chemical signatures older than the solar system itself. If its motion continues to shift in these quiet, incremental ways, then scientists will confront a new category of interstellar object, one shaped not by chaos, but by layers of stability that adjust in silence. Humanity has seen supernova, gamma-ray bursts, plasma arcs, collapsing stars. But Atlas offers a rarer lesson, that sometimes the universe does not shout its mysteries, it whispers them. And those whispers, subtle as they are, may reshape our understanding of what moves between the stars. For now, the responsible scientific position is clear. The trajectory has changed. The cause remains unknown. And the implications are widening every hour. What happens next, whether revealed by Mars, ESA, or a distant orbiter catching a fleeting streak of reflected sunlight, will define how we interpret every interstellar visitor that follows. Until then, the universe leaves us with a single unsettling truth. 3IATLAS is not behaving like anything we have seen before, and the silence surrounding its motion speaks louder than any plume or flare ever could.